Hello everyone, I'm Dharani Palanivel and today I'll be presenting my technical review on Azure Cosmos DB. I chose Cosmos DB because my data set is in JSON format and Cosmos DB is designed specifically for storing and querying JSON documents efficiently. It provides automatic indexing, low latency reads, horizontal scalability, and helpful tools like query starts for analyzing RU consumption and query performance. These features make it a suitable choice for analytical workloads and for demonstrating performance optimization, which is required for this project. So before I begin the demo, I want to briefly explain the two login options that is provided by Azure. So Azure provides two ways to sign in. The one is the normal Azure free account and the other is the Azure for Students login. The normal Azure free account gives USD 200 of credit for 30 days, after which it switches to pay as you go. The Azure for Students login, which is linked to my NGO account, provides USD 100 of free credits without needing a credit card. So for this project, I'm using the Azure for Students login because all my Cosmos DB resources and configurations were created under the subscription, and the free student credits are more than sufficient for the entire assignment. So let's begin the project demonstration. Just sign in through the Azure for Students option and enter your NTU student credentials, and Azure would automatically verify the student subscription. So once you log in, you would find this Explorer homepage and you could see the rest of the tools that are offered by Azure. But now let me start with setting up Azure Cosmos DB. So here you could see the create button for Azure Cosmos DB, and there are two options for Azure Cosmos DB, one for NoSQL and one for MongoDB. I've picked the NoSQL version. Let's begin. So in the basics page, we have all these options, and for workload type, we have three options. So I'm picking development and testing. And for subscription, we have Azure for students, and for resource group, you could have it in any name. So for now, I'm have it in as ABC, and the account name could be your name or any other name that you would prefer. And the availability zones would be in disable, and the location would be Malaysia West. And for capacity mode, we'll have it as serverless. So the next one is global distribution. So you could see it is disabled because this project only needs a single region deployment. And then we have networking. In the networking, I kept connectivity methods, all networks, which is the simplest option for deployment. And for backup policy, I kept the default option periodic, and you could choose either between locally redundant backup storage or zone redundant backup storage. I'm picking locally redundant backup storage. And for security, I kept key-based authentication enabled, and I used service management key for the data encryption. And then the tags, I did not add any tags, so I left this section empty. And that's it. Like we just need to review, and after it is successfully validated, we could create, and DB would be created. My data explorer view inside the Cosmos DB account, and the left panel here shows the overall structure of the database. So in Cosmos DB, database is the top level container used to group related data. And inside the database, we create a container, which is the main data storage unit. Container is similar to a table in a relational database, but in Cosmos DB, it stores JSON documents. So each record here are stored as items. So, and every item is stored as a JSON document. So for this project, I created one database called Happiness Insight, and inside it, I created one container named Country Scores. So this container holds all country level JSON documents that I will be querying. So to create the structure, I used a new container option, and here you could see we could give a database name. So in my project, I gave it as Happiness Insights, and for container ID, I gave it as Country Scores. And the partition key is a required setting here, and I used country because most of the queries are country based, and this gives efficient partitioning and better performance. I did not add any unique keys, and I kept the analytical store turned off. since a project does not require large-scale analytical workloads. So once these fields are completed, I clicked enable, and the database and the container was created over here. So, well, coming to the items section, and we see all the records are stored as individual JSON documents. So each item represents a country year data point. So on the left of my container named country scores, and in the middle panel, Azure displays the list of items that are available. And when I clicked any item, I could see the full JSON document shown on the right. So each document here contains the key fields used in my analysis, including the country, year, happiness score, uh, GDP, trust, health index, and so on. So because Cosmos DB is a NoSQL document database, the structure is flexible and stored in JSON rather than rows and columns. So to populate the container, I use new item option over here. And so for each document, I pasted the JSON content similar to uh, all of this that I've shown earlier. And I saved the item immediately, and it was stored under the container. I repeated the process for all of the countries and years in my data set, resulting in a clean collection of JSON items. So I have overall 15 JSON items available in my item set. So, and one more thing is that Cosmos DB does not support uploading a full JSON file directly in the Azure portal. So, manual insertion through new item was the most suitable method for this project. So for larger data set, bulk file uploads can be done using external tools such as the data migration tool or SDK scripts. And this limitation applies only to the Data Explorer interface. And then we have the settings panel. So under the settings panel, we have certain fields here and several default configurations that are already optimized for most workloads are present here. So in general settings, we have the time to live, which is off and which is default, and which means my documents do not expire automatically. And the geospatial mode is set to geography, which is the standard default for non-spatial JSON data. And in the container policy tab, I uh, uh, kept it as default language in English, and the indexing policy tab is the most important one here. So the indexing policy tab shows that the Cosmos DB automatically applies the default indexing. So this means every document and every property is indexed automatically without me having to create indexes manually. So the default indexing mode is consistent, and the automatic indexing is turned on. And so every new item I insert is immediately indexed. So this makes the query fast and ensures I can filter or sort by any fields at any time. And for the partition keys, as mentioned earlier, I kept it as country during the setup. And the last one is computed properties tab. So here it is empty by default, but because no computed fields are required for my data set. So overall, Cosmos DB default settings are efficient and ready for use without any additional configuration. Start with the querying part. So in the querying part, let's give a new SQL query option, and you could see we have a new file where we could write our queries. And I'll begin with giving a new query. And here we have three options: one for executing, saving, and downloading query. We could also save the queries and also download the queries for later uh, future use. And while executing queries, I get two tabs, one for results. So my query first to get the country, year, and happiness score based on the country Finland, ordered by year. So we have 3 years and it's Finland's happiness score for all these 3 years. We could also copy the results or download the results in the form of JSON or CSV format. And I have this another option called query stats where we have certain properties where my request charge was 2.89 IUs, which is the uh, performance cost of this specific operation that we performed in the query. So for every operation, we have different type of IUs and different amount of IUs. So more complex the queries, the more the performance or the performance cost is, and the less complex the queries are, the less performance cost is. And we have certain other properties like download load time, document write time, and round trips. So this is about the queries. I have certain other queries that I done for my data set. So here we could see I have took an analytical query where I have taken happiness score greater than 7 and trust less greater than 0.7. And I have selected country happiness score and trust in government columns, and I've ordered by happiness score. And you could see Finland as the highest happiness score and highest trust in government compared to the rest of the countries. So Finland is one of the happiest nations, and it always ranks first in the happiness index. And then I have one more query to show the aggregate functions. We have average, so I took average happiness score as average happiness, and I selected country. So I've grouped by country, and we could see the average happiness score for each and every country over here. So this is about aggregate functions, and so we have one more query here. So let's see what happens when I execute this query. So you could see the query has failed. Let's see why. And the error states that the order by query does not correspond composite index that it can't be served from. So when I ran the query that ordered the data by both country and year, Cosmos DB returned an error because multi-property sorting across partitions is not supported without a composite index. And since my partition key is based on country, each country's documents are stored in separate logical partitions, and the default indexing policy only creates single field range indexes, which cannot handle combined ordering on more than one property. So to resolve this, I'm just replacing the default indexing policy with a composite indexing thing based on country and year. And I'm saving it to understand how the query works after changing it into the composite indexing. So this would create a joint sorted structure that allows Cosmos DB to execute multi-property sorting correctly and efficiently. Now let's execute this query because it got saved now. While I executed the query, it ran successfully and it has returned the happiness score based on year and country. So it has ordered by both year and country successfully. So this shows that the index was used wisely and efficiently. So beyond composite indexing, Cosmos DB also provides additional indexing types such as range indexes for filtering and ordering numeric or string values, and hash indexes for fast equality lookups, and spatial indexes for geographical data. So together, these indexing options also allows Cosmos DB to optimize different query patterns and improve overall query performance depending on the structure of data. So for this project, I used the default consistency level and kept the throughput settings unchanged as the autoscale configuration provided more than enough capacity for my workload. And we could also download these query results and then connect it to a Jupyter notebook and derive analytical visuals and connect it to the Excel sheets to create visualization graphs or plots to understand the analytical part. And overall, this project showed how Cosmos DB manages JSON data efficiently and how its indexing and query tools support fast and optimized analytical queries. So, yeah, thank you.